In the corner of technical college workshops from Yorkshire to Queensland sits a machine painted a particular shade of grey. 13 inches of swing over the bed, around 600 kilograms of cast iron, and a nameplate that reads, Harrison M300. If you learned to cut metal at any point in the last 50 years, there is a good chance you learned on one of them. It stayed in production for 46 years. What almost nobody standing at that machine ever knew was that the company which built it spent most of those years fighting simply to stay alive. You are watching Trade Archive. Heckmondwike, West Yorkshire, 1898. The town sat in the middle of what people called the Heavy Woollen District, a run of mill towns west of Leeds, where the air smelled of lanolin and coal smoke, and the entire local economy rested on cloth, blankets, and worsted. Shoddy and mungo, the reclaimed wool pulled back out of rags and spun again into something sellable. Every street had a mill, every mill had looms, and every loom, sooner or later, broke. That year, a man named Thomas Strickland Harrison opened a small repair shop in Heckmondwike, powered by steam, and went into business with his two sons, Tom and John. They were not machine tool builders. They were textile machinery men, and the work was exactly what it sounds like. A carding engine seizes, a loom throws a shaft. A mill owner who is losing money by the hour needs it running again by morning, and somebody has to make the part that will do it. Repair work teaches you something that manufacturing does not. You spend your days inside other people's machines, looking at how they were designed and, more usefully, how they failed. Harrison and his sons were doing that 6 days a week across a district packed with machinery, and the thing they kept running into was a bottleneck in their own shop. To fix a broken loom, you need turned parts, shafts, bushes, spindles, collars. To make turned parts, you need a lathe. So in 1900, 2 years after opening the doors, they built one. It was a treadle machine. No motor, no line shafting, no steam belt overhead. The operator stood at the machine and worked a hinged board with his foot, and that board drove a crank, and that crank turned the spindle. Every revolution of the workpiece came out of the operator's own leg. It is the oldest arrangement in metalworking, and by 1900 it was already old-fashioned in any factory that could afford power. But there were thousands of workshops that could not. Village blacksmiths, jobbing engineers, repair shops exactly like Harrison's own, scattered across a country that ran on machinery it could not always afford to replace. That first lathe is the moment the company stops being one thing and starts being another. Harrison had been in the business of fixing machines that other people built. From 1900, he was in the business of building machines that other people would use to fix everything else. It is a smaller market in one sense and an infinitely larger one in another, because a lathe is not a product. A lathe is a machine that makes products, including, eventually, more lathes. In 1916, in the middle of the First World War, the firm became a limited company under the name T.S. Harrison and Sons Limited. What follows over the next 20 years is the least documented stretch of the company's history, and it is worth being honest about that. Harrison spent the interwar decades building belt-driven lathes for the general engineering trade, and the surviving record is thin. The machine tool archive kept by Tony Griffiths, which is the closest thing this industry has to a proper museum, notes flat-belt Harrison lathes on the books by 1938. It also notes something that still causes problems today. For years, Harrison identified its machines not by a model name, but by center height. A 9-inch, an 11-inch, a 13-inch. Plenty of them left the factory without a model plate at all. The result is that a restorer who drags a pre-war Harrison out of a barn today often cannot tell you precisely what he has bought. The castings are unmistakable. The paperwork does not exist. Machines that were built to last a century were not built to be catalogued, because in 1930, nobody in Heckmondwike imagined that anyone in 2020 would care. Then the country needed lathes. In 1941, T.S. Harrison and Sons was taken over by the Brooke Tool Manufacturing Company for war production. Brooke Tools was a Birmingham firm based on Warwick Road in Greet, founded in 1903 to bring two smaller tool-making businesses under one roof. In 1913, a controlling interest in it had been acquired by Alfred Owen of the Midlands industrial dynasty that would become Rubery Owen, one of the great British engineering families of the 20th century. So the arrangement that took shape in 1941 was this. A family repair shop in a West Yorkshire mill town, still trading under the founder's name, now sat inside a Midlands industrial empire because a war cabinet had worked out that you cannot fight a mechanized war without machine tools. The logic was brutally simple. Shell casings are turned, aircraft engine valves are turned, gun barrels, torpedo components, hydraulic rams, every rotating part of every vehicle in the inventory. Machine tools sit one layer beneath the war effort, invisible in the newsreels, and the country did not have enough of them. Here is where the record goes quiet in a way that is genuinely frustrating. There is no surviving account of what specifically came off the Heckmondwike floor between 1941 and 1945. No production ledger, no list of contracts, no photograph of a shop full of women turning shell bodies, though there almost certainly was one, because that was true of nearly every machine shop in Britain. The company's own history records the takeover and then skips to the outcome, and the outcome is a number. By 1949, according to a report in The Times that May, Harrison's turnover had increased fourfold since 1941, 4 times larger in 8 years. That is what happens when a small firm is handed capital, government orders, and permission to expand all at once. Brooke Tools had not bought a repair shop. They had bought a production capacity, and they scaled it. The war ended, and the orders did not stop. Europe had to be rebuilt, and rebuilding requires factories, and factories require lathes. A British machine tool builder in 1947 was selling into a continent where a great deal of the competition had been bombed flat. Harrison came out of the 1940s with a workforce it had grown, a factory it had modernized, and a domestic reputation built on one specific quality. Not precision, particularly, and not sophistication. Ruggedness. Harrison lathes had a reputation for being difficult to kill. That reputation has a name, and the name is the L5. Introduced in the early 1940s, the L5 was a 9-inch swing-geared head lathe. No belt cones to change, no countershaft hanging from the ceiling. The gears were in the headstock, the speeds were selected by lever, and the machine had a clutch. It was the smallest, genuinely industrial lathe Harrison built, and it sold at a price that put it inside reach of shops that could never have justified a 16-inch machine. Roughly 180 pounds, against about 560 for the big one. It is worth pausing on what a geared head machine with a clutch actually meant to a working shop in 1948, because it is easy to miss from this distance. The lathes it replaced ran off a flat belt from a countershaft, and changing spindle speed meant stopping, walking round, and shifting that belt by hand across a stepped cone pulley. On a busy job, you did not bother. You picked one speed and lived with it, cutting too slow on small diameters and too fast on large ones, and the finish and the tool life suffered accordingly. A geared head with a clutch let the operator select the right speed with a lever in seconds and stop and restart the spindle without touching the motor. It sounds trivial. Multiplied across a working day, it is the difference between a machine that gets used properly and one that does not. Then came the L5A, and this is the one that mattered. Same bed casting, same basic architecture, but opened out to give 11 inches of swing instead of 9. For a small increase in price, you got a machine that could take substantially larger work, and the trade noticed immediately. The L5A became, in the judgment of the Machine Tool Archive, simply the better buy. Both were offered with a 24-inch or a 40-inch bed, depending on how much floor a shop could spare, and both could be fitted with hydraulic copying gear for turning the same profile over and over without a skilled hand on the cross slide. They went everywhere, schools, colleges, workshops, light industry, across Britain and out across the Commonwealth. And here is where something strange starts happening to the badges. By the middle of the 1960s, the 11-inch Harrison was being sold in the United States and Canada under a completely different name. It was badged as a Clearing. Other Harrison machines went out wearing a DoAll plate. The lathe was identical. The castings were poured in Yorkshire, and the nameplate was chosen by whoever was selling it on the far side of the Atlantic. Because in a market where American buyers had their own loyalties, the name on the headstock was a commercial decision rather than a statement of fact. Through the 1950s, the range grew heavier. Larger swings, more mass, and the arrival of variable speed drives, which let an operator change spindle speed continuously rather than jumping between fixed gear steps. Harrison was moving out of the small workshop and onto the industrial floor. It is worth understanding what building one of these actually involved, because the phrase machine tool manufacturing hides an enormous amount of patience. Everything starts with the bed, the long-ribbed casting that every other part of the lathe is bolted to or slides along. It is poured in iron, and then it is left alone. A fresh casting is full of internal stress from uneven cooling, and if you machine it straight away, it will move afterwards, quietly, over months, and take your accuracy with it. So the castings sit and settle before anybody touches them. Then the ways, the precision surfaces the saddle and tailstock run on, are ground rather than merely machined, on dedicated grinders that do nothing else. The gears are cut on generating machines, hardened, and ground again after hardening, because heat treatment distorts a gear, and a distorted gear is a noisy gear. Only then does assembly begin, and at the sister Colchester factory, the archive record of the period describes what happened next in plain terms. A great deal of careful hand-fitting. A man with a scraper and a surface plate, taking microns off a casting by hand, checking, and taking a little more, until two surfaces bed together properly. No drawing can specify that. It is transferred from one fitter to the next by watching. And then, in 1961, they changed how the machines were built. Up to that point, a lathe was assembled the way lathes had always been assembled. The machine stood in a bay. The fitters came to it. A skilled man spent days on one machine, hand-fitting and hand-scraping mating surfaces until the saddle slid along the bed with the right feel, which is a judgment made by hand and eye and cannot be specified on a drawing. It produced superb machines slowly, and it produced them at whatever rate the fitters could manage. In 1961, Harrison installed a mechanized conveyor line for final assembly, which the company recorded as the first of its kind in the United Kingdom's machine tool industry. The machine now moved and the men stayed still. Work was divided, sequenced, and timed. It is the same logic Ford applied to cars 40 years earlier, arriving late in an industry that had resisted it for a good reason, because a machine tool is not a car. A car has to work. A machine tool has to be accurate enough to make the parts for cars, which is a different and much harder standard. Harrison's bet was that you could impose flow production on precision engineering without giving up the accuracy, holding on to hand-fitting where it genuinely mattered, and taking it out everywhere it did not. The bet paid. By 1968, Harrison's exports passed 40% of total output for the first time in the company's history. Two things were happening alongside the center lathes that are easy to skip and shouldn't be. The first is that Harrison had quietly become one of the most respected wood-turning lathe builders in Britain. The Graduate, with 6 inches of center height and beds offered at 30, 42, and 54 inches between centers, went into school woodwork rooms and professional turning shops, and simply never left. The lighter Jubilee did the same at a lower price. There are woodturners today who will argue that a well-kept Graduate is still the best machine of its type ever made in this country, and they will argue it at length. The second is a range of high-accuracy toolroom lathes carrying the AA designation: VS330, the 10AA, the 13AA. These were not production machines. They were the lathes you bought when the part had to be right for tool and die work and instrument making, and they sat at the top of Harrison's accuracy ladder. And inside that range sits one of the strangest details in the whole story. The 10 AAVS, sold under the Harrison name for export, was a rebadged Colchester Chipmaster. Colchester, the lathe firm down in Essex, founded in 1887, and the single biggest rival Harrison had in the British market. If you were an engineering apprentice in 1965, you argued about Colchester versus Harrison, the way you argued about Ford versus Vauxhall. And here was Harrison, shipping a Colchester overseas with its own name on the front. The rivalry was real. It was also, at the commercial level where the money actually moved, considerably more flexible than anybody on the shop floor believed. Which is a useful thing to know, because of what happened in 1971. The 600 Group took its name from an address, 600 Commercial Road in the East End of London, where a firm called George Cohen and Company had its offices. Cohen's had been founded in 1834, and their business was not machine tools. It was scrap, metal recovery, demolition, and the industrial dismantling of things too big for anyone else to touch. After the First World War, they cleared 400,000 tons of high explosive and other shells. They took down the towers of the Crystal Palace. Scrap merchants sit in an unusual position in an industrial economy. They see which factories are closing before the closures are announced. They know what plant is worth, and they accumulate cash. In 1954, the 600 Group used that position to buy the Colchester Lathe Company, and in 1971, they bought Harrison. Consider how that lands on the floor at Heckmondwike. The firm that had beaten your machines on price and lost to them on toughness for 2 generations, the firm you defined yourself against, is now your sister company. Both of you are owned by a scrap metal business from the commercial road. Every argument you have had since the war has been settled by an accountant in London. 1971 is also, and this is not a coincidence, the year Harrison launched the M300. Look at what the group could now put into a single machine. The spindle ran in Gamut super precision opposed thrust roller bearings, and Gamut was itself a 600 Group subsidiary, founded in 1956 on technology brought over from France and built up at Colchester. The group owned its own bearing company. So the most critical component in the lathe, the one that determines whether the machine can hold a tolerance under a heavy interrupted cut, came from inside the family and was made to the group's own standard. The bedways were induction-hardened and precision-ground, which matters because a lathe wears where the saddle slides, and a soft bed is a machine with an expiry date. The spindle nose was a number 4 D1 cam lock, a taper and cam arrangement that lets a chuck be swapped in under a minute and, critically, cannot unscrew itself when the spindle is thrown into reverse. 38mm bore through the spindle. Number 5, Morse taper in the nose. Number 3 in the tailstock. 3 horsepower, 12 speeds, 40 revolutions a minute at the bottom end for heavy work, and 2,500 at the top for small diameters in free cutting material. The screw-cutting gearbox was the party piece. 3 levers and a dial, hardened and ground gears running in an oil bath inside a single casting, and from that you could cut 35 English pitches, 39 metric, 18 module, and 18 diametral. A machine that could thread anything a British, European, or American drawing was likely to ask for, selected by hand in a few seconds, with the chart cast into the machine in front of you. The lead screw and the feed shaft were protected. Early machines used a shear pin, later ones a torque-limiting clutch, and the purpose of both was the same. When the carriage is driven hard into the chuck, or a student takes a cut, the machine has no business taking. Something cheap gives way before something expensive does. The drive disengages. The gearbox survives. As the Machine Tool Archive puts it, the arrangement existed to limit the damage caused by the overambitious cuts routinely set up by apprentices and by the overenthusiastic amateur. Harrison had designed a machine that expected to be crashed. Every technical college in the country was buying lathes for 18-year-olds who had never touched one. The colleges did not need the most accurate machine on the market. They needed a machine that would survive 4 decades of being crashed by people who were still learning and would still be turning true at the end of it. Harrison built exactly that, shipped each one with a final inspection chart, and then kept building it with detail changes for 46 years. It was sold in the United States as the DoAll 13-inch. It was sold as the Colchester Student. It was rebadged for South Bend. The machine outlived the name on its own front panel several times over. There is a strange afterlife to all of this. Search the machinist forums today, on Practical Machinist or the Home Shop Machinist board, and the M300 comes up constantly, usually in the same tone people use about a car they regret selling. An owner in the United States describes buying what he thought was a DoAll and discovering it was a Harrison M300 with new badges. Precision shooting forums argue about barrel work, and someone points out that the M300 can hang with machines costing several times as much. Men who bought an L5A 40 years ago report, without much sentiment, that it made them a lot of money. These machines are being pulled out of closed factories and rebuilt in garages. Somebody strips a 50-year-old lathe, has the bed reground, scrapes the saddle back in, and puts it back to work. That does not happen to equipment that was merely adequate. It happens to equipment that people believe is worth the effort, and Harrison spent 70 years earning that belief one Yorkshire casting at a time. By the end of the 1970s, the 600 group had assembled the pieces around them. Gamut bearings came fully into the fold in 1979, Pratt Bernard, the chuck maker, in 1981, and Clausing Industrial of Kalamazoo, Michigan, a firm dating to 1911, became the group's North American arm-handling Harrison sales and service. On paper, it looked like an empire. Bearings, chucks, lathes, distribution, all under one owner. What it actually was, though nobody in Heckmondwike could see it yet, was a British industry consolidating itself into a smaller and smaller number of buildings. In 1992, the last wall came down. Colchester and Harrison were formally amalgamated into a single business, 600 lathes. After a century of arguing about which was the better machine, the answer became administrative. They were the same company now, and the surviving entity would be folded again into 600 UK in 2009. But before all that, Harrison had one more genuinely original idea left. In 1995, at the EMO Machine Tool Exhibition in Italy, the company launched the Alpha. The problem it solved was specific. Computer-controlled turning centers could outproduce any manual lathe on a long run, and no toolroom foreman disputed it. But a toolroom does not do long runs. It makes one of something today, because a line is stopped and a shaft has broken, and writing a program for one part is slower than just making the part. The Alpha put the control on the manual machine. Fanuc electronics, a conversational teach-in system rather than raw code, and a screen that asked the operator what he wanted, instead of demanding he speak the machine's language. Face this diameter, turn this taper, cut this thread, and the control worked out the tool path. Critically, Harrison kept the hand wheels. A man who just needed to skim a face could walk up and use it as a lathe, exactly as he had for 30 years, and never touch the screen. The range grew for 2 decades, up to machines with live tooling that could mill as well as turn. It became a fixture in training centers worldwide for the same reason the M300 had, because a student could learn manual turning and CNC on one machine. It was a good answer. It was not an answer to the question that was actually going to decide the company's future. That question was cost. By the middle of the 2000s, the arithmetic on a British-built center lathe had stopped working. Taiwanese and Chinese builders were selling machines that did most of what a Harrison did for a fraction of the price, and the buyers making that comparison were not sentimental. In 2005, the group's managing director Mike Berry laid out where the money was going, and the numbers tell you the decision had already been half made. Around 28% of costs were still British. More than 30% were Chinese. A quarter came from Taiwan and the wider Far East. Between 2005 and 2007, the company moved conventional lathe manufacture to the Dalian Machine Tool Group in China. The trade press would later refer to it, flatly, as the disastrous Dalian sourcing project. So they tried Poland. In late 2010, the 600 Group bought a former state-owned armaments factory in Tarnow from the Polish weapons group Bumar, reportedly for around €1 million, intending to build the whole conventional range there. The M300, the Colchester Student, the Master, the Triumph, the Mascot, the Mastiff, and the Alpha. Chairman Martin Temple called the move transformational. They were out within 2 years. The Tarnow venture was abandoned around 2012. The plant passed to a German buyer and was bankrupt by the middle of 2013. Reporting in the Yorkshire Post put the cost of the whole Polish adventure to the 600 Group at somewhere between £3.5 million and £4 million. In the space of 7 years, the company had shipped its manufacturing to China, found that it did not work, shipped it to Poland, and found that it did not work either. By then, the damage had reached the accounts. In the financial year to 2012, the group recorded a net loss of about £15 million on a turnover of roughly £40 million. A business turning over £40 million does not lose 15 of them twice. Nigel Rogers arrived as chief executive in March 2012, walking into precisely that, and did something that in 2012 sounded eccentric. He brought the work back, not out of patriotism. Components were sourced from Taiwan, where the quality was good and the price was survivable, and the machines were finished and assembled in Heckmondwike. British content went above 60%. Nothing came from China. The reasoning, as Barry explained it, was that customers in Britain and Europe wanted a machine built in Britain and would pay a premium for one, provided the premium stayed within reason. It worked. By the 2013 to 2014 financial year, that £15 million loss had become a net profit of about £2 million on similar turnover. The reshored operation built 30 to 40 machines a month on a single shift and held £4 million of spares, enough to support machines up to 50 years old. Rogers left in 2015, brief having been met. But look at what was left standing in Heckmondwike. The site ran to around 225,000 square feet, built for a workforce that had once numbered in the several hundreds. The revived operation employed about 80 people in a little under a third of it. The conveyor line of 1961 had been laid down for a company that expected to keep growing. What was left was a smaller, sharper, more profitable business occupying the corner of a factory designed for a country that no longer existed. And there was one more thing holding the whole enterprise by the throat. During the decades when Harrison and Colchester employed hundreds of people, those people had been promised defined benefit pensions, guaranteed sums for life. The promise was made when the business was large and the retirees were few, and it was entirely reasonable at the time. By the 2010s, it had inverted. The scheme covered around 2,000 pensioners and 800 deferred members. The company paying for it employed a fraction of that number. The liability sat at £201 million, roughly $270 million. The trading business underneath it was turning over 40. The group's executive chairman, Paul Dupuy, described the situation to shareholders without much decoration. A prominent portfolio manager, he noted, had observed that the scheme effectively controlled the company. There were undertakings and security arrangements in place that severely limited what the business could do with its own money. In July 2018, the trustees agreed to hand the entire £201 million liability to Pension Insurance Corporation, a specialist insurer, in a full buyout. It completed in May 2019. The pensions were secured with an insurance company rather than resting on the survival of a machine tool firm, and the 600 Group was free for the first time in decades, with a modest surplus coming back the other way. Dupuis's description afterwards was that the shackles had been thrown off. Harrison had survived 2 world wars, a takeover, a merger with its oldest rival, the arrival of computer control, 2 failed attempts to manufacture abroad, and the collapse of the British machine tool industry around it. What nearly finished it was a promise made to its own workforce in better years. If you want more of these stories, subscribe to Trade Archive. There is another one waiting on screen now.